All right, hey y'all. Today we're going to solve equations with rational exponents. We've been working with rational exponents and trying to figure out how to use our rational exponents to make problems easier for ourselves, and now we're going to translate that into equations. This is just a hint. When you have exponents other than 1/2, 1/3, 1/4, when you have basically if the numerator is something different, you're going to break it into parts to make it easier. For example, if your exponent is 2/3, we have a hard time calculating an exponent to 2/3. So what I'm telling you to do is break it up into two parts. A fraction with a numerator of 1, so 1/3, then times 2. So when you multiply this, you still get 2/3, but this will be much more easy to calculate. Same thing right here. 3/2. Break it up into 1/2 times 3. So let me give you an example. Let's say you have 16 to the 3/4. When we say 16 to the 3/4, it doesn't mean very much to us at the moment. So break it up into 1/4 and 3. So you notice I broke it up into 1/4 and 3. We can calculate the 4th root of 16. Hopefully you've done that enough now that you know the 4th root of 16 means what number times itself 4 times will give you 16. And I've shown you here the 4th root of 16 raised to the 3rd power. So the 4th root of 16 is 2. And 2 to the 3rd power is 8. Going all the way back, 16 to the 3/4 power doesn't mean much to us, but if you break it up into those parts, then you can do little part by taking the 4th root and then cubing it. Now, I am not going to tell you this is going to be quick because there are lots of examples, but I want to make sure I'm very thorough and I go over lots of different examples with you. So when you have an even index, remember that you have to take the plus and minus. Oh, it's crowded outside. When you have an even index, take the plus and the minus. That means the positive and the negative root. Yes. Bye. No, I'm recording. You're okay. All right, so example 1. The 4th root of a equals 14. So to undo a 4th root, you have an option. You can do to the 4th power, because the 4th root and to the 4th power are going to undo each other, or you can change it to a fraction, a to the 1/4 equals 14. And then, in order to simplify it from here, we want to have a to the exponent of 1. Because a to the 1 is just 1. So you'd have to figure out what can I multiply 1/4 by to get 1. So 1/4 times what will just give us 1, or 1/1. So if you look at that, hopefully you can see the pattern, but I'll go ahead and tell you. If you have a fraction, you're going to multiply by the reciprocal to get 1. So 1/4 times 4/1 is going to give us 1. So right here, we're going to raise it to the 4th power, and you notice it's the same thing on both sides. So 14 to the 4th power is 38,416. Right. Now, when we do more examples, I'll show you when that comes in handy. Number 2, a cubed to the 4th root equals 27. That doesn't mean much to me at the moment, so let me show you what works for me. I'm going to rewrite it using fractional exponents. So I know that's going to be a to the 3/4 power equals 27. To solve this, when you have a fractional exponent, you're going to raise everything to the reciprocal. You're going to flip it. So instead of 3/4, I'm going to raise it to the 4/3. These basically are going to multiply to be 1, which is a. 27 to the 4/3 power. If you have a calculator, by all means, type it out in your calculator. But if not, this is when we go back to what I just showed you. 4/3 can be written as 1/3 times 4. So if we use that information, I know it's going to be 27 to the 1/3 power raised to the 4th. 27 to the third power, that's a cubed root of 27, which is 3. And 3 to the fourth power is 81. So I know that A has to be 81. Question number 3. X to the 1/4 minus 2 equals 3. First thing we have to do is move this 2 over by adding 2 to both sides. And I get 5. Now this looks a lot like this over here. To solve it, if it's raised to the 1/4 power, you're going to raise it to the reciprocal. So I'm going to raise it to the 4th power. And those are going to cancel, and 5 to the 4th power is 625. Number 4. Again, I have a problem, and right here I have an exponent. Now it's not a fractional exponent, so this one will be a bit different. I'm going to add 6 to both sides. And I get 4x to the 7th power equals 4. You need to divide both sides by 4. And x to the 7th equals 1. So here's where it kind of is a little easier for you. To undo an exponent of 7, we have to take the 7th root. When you have an exponent, like an exponent of 2, a 3, a 4, you take the square root, the cube root, the 4th root. So if you have an exponent of 7, you're going to take the 7th root. Is this an even root? No, it's not. It's an odd root. So I don't need to do a plus or minus. This is a positive, and the 7th root of 1 is just 1. All right, example number 5. You need to add 5 to both sides. So the square root of x equals 5. To undo a square root, you would have to square both sides. And x equals 25. So the square root of 25 is 5. All right, some more examples. Example 6 can look intimidating, so let me help you. I'm going to break it down. First thing we need to do is get rid of this 3. So we're going to divide by 3. And then we're left with x to the 2/3 plus 5 equals, I don't know, 69 maybe? Yeah, 69. Then I need to move that 5 over. You can't have that 5. So x to the 2/3 equals 64. Now I have x to the 2/3. I need to get rid of that. I need to undo that exponent of 2/3 by raising it to the reciprocal. So I'm going to raise both sides to the 3/2. By raising it to the reciprocal, these are going to multiply, and then you have x to the 1st power. Now, 64 to the 3/2 power. That is not easy for me to calculate anyways. And you probably are not going to have a calculator for most of these. So 3/2, I can break that into 1/2 times 3. 1/2 is really nice because we know the square root 64, the square root of 64 is 8. And then 8 to the 3rd power would be 64 times 8. I don't know that. 64 times 8. And you get 512. Now let me just go back. Breaking it up into a 1/2 power is the same thing as taking the square root. So whenever you can break something into a 1/2 power, that's the same thing as taking a square root. Example 7. Everything in here is under the cube radical, the cube root. So I can't move the 2 over because it's being blocked by the radical. To undo the radical, you can cube both sides. And then I'm left with x minus 2 equals 64. Because 4 to the 3rd power is 64. Now I have a simple one-step equation. You add 2 to both sides, and x equals 66. Number 8 looks a lot like number 7, except I have this minus 2 that's not under the radical, so I need to move it over by adding 2 to both sides. And I get the square root of a plus 2 equals 14. This is a square root. To undo a square root, You would square both sides. And then a plus 2 is going to equal 196 because 14 squared is 196. You subtract 2 from both sides, and a equals 194. Okay. Number 9. We have this fractional exponent, so you can undo that by raising everything to the reciprocal power, 2 over 1, which is 2. Anytime you have a fractional exponent, if you're trying to solve an equation, you raise it to the reciprocal power. So I need to raise this to a 2. Those cancel, and I'm left with 2x plus 7. 3 squared is 9. I'm going to subtract 7 on both sides, and I get 2x equals 2. And then I divide both sides by 2, and I get 1. So x equals 1. So 2 more for you, and this, sometimes answers don't work. So let me explain what I mean by that. When you have to take the square root and you have 2 answers, like a positive and a negative, like when we were doing quadratics, you are used to seeing like a is plus or minus 3 or positive 1 and negative 2. Well, sometimes one of those answers might not work. And if that's the case, you want to try them to make sure they work. So look at number 10. I'm going to add 2 to both sides. So I get a plus 2 equals a plus 2. In order to get rid of the square root, I must square both sides. And that cancels, so I'm left with a plus 2. And over here I have a binomial that I need to multiply, and I'm going to be left with a squared plus 4a plus 4. Okay. Sent you in here? Okay, just sit. To solve this equation, I need to move everything over and set it equal to 0, just like a quadratic. So this is like a quadratic function. A quadratic equation. I'm going to move these over, so I'm going to subtract a, subtract 2, and I'm left with a squared plus 3a plus 2. I think factoring is going to be the easiest way, so let's go back to factoring. And I know that since this is positive, they're both going to either be positive or negative. They're both positive. And to get 2 times 1, so this would be 2 and 1. And a, when you solve it, a is going to be negative 2 or negative 1. So those are what we're saying are our solutions. Now, to test our solutions, we would want to go back over here, and we'd want to test them. So first, let's test negative 2. All right? Negative 2 plus 2, right here, negative 2 plus 2 is 0. 0 minus 2 is negative 2. And a is negative 2. So negative 2 equals negative 2. Yes, that checks out. So negative 2 works. Now let's test negative 1. Negative 1 plus 2 is 1. Negative 1 plus 2 is 1. The square root of 1 is 1. 1 minus 2 is negative 1. And a is equal to negative 1. So that works. So both of these work. So they're both our solutions. Number 11. We need to move the x over. So we have 2x plus 7 to the 1/2 equals x plus 2. Same thing. This is a square root, and this is an exponent of 1/2, but they're the same thing. So to undo it, we're going to raise everything to the second power. We're left with 2x plus 7, and over here we're going to have x squared plus 4x plus 4. I'm going to move it all over so I can solve this quadratic equation. So minus 2x minus 7, and I'm left with x squared plus 2x minus 3 equals 0. I know I can factor, so I'm going to factor an x. To get a negative 3, that means I need to have 1 plus, 1 minus. And my factors of 3 are going to be 3 and 1. To have a positive 2, I know that I need my 3 to be positive and my 1 to be minus. And when I solve it, I get x equals -3 and +1. Now let's test them to make sure. When I go up here and I put a -3 in, right here, -3. So 2 times -3 is -6, plus 7 is 1, square root of 1 is 1. 1 minus -3 is 4. Does 4 equal 2? No. Now if you didn't follow that, rewind it again. I substituted -3 and I worked it out, and -3 does not work. Now let's try 1. 2 times 1 is 2. 2 times 1 is 2. Plus 7 is 9. The square root of 9 is 3. And 3 minus 1 is 2. And that does work. So 1 is our only answer that works. -3 does not work. Okay, so I know that was a lot, so we'll practice more.